Hello, everyone. My name is Catarina Madeira, and I'm a program director at the MIT Startup Exchange. On behalf of our team, I'm delighted to welcome you all to the Startup Lightning Talks. I'll start with a brief overview about the program, and then we'll hear from 10 of our amazing entrepreneurs. So Startup Exchange was created about 7 years ago within MIT Corporate Relations. And today we support a network of about 1,400 startups and over 230 corporate members. These are these are global corporates that are working across sectors. Typically, on average, we facilitate over 600 introductions. What is this?
Use the click.
Okay, this one? Okay, thank you. I'm sorry. We facilitate over 600 highly vetted introductions between them, and these are some of the success cases we had so far that include pilots, license deals, customer agreements, and other kinds of partnerships as well. Startup Exchange is sector and geography agnostic, and we mostly support B2B startups. And these are some of the trending technologies that we've been seeing more lately. So how can you, as an ILP member, engage with all these startups? Well, one way is to participate at events like today's. You can meet entrepreneurs on a one-on-one as well with the help of your ILP program director and the Startup Exchange team too. You also have access to STEX25, our program accelerator, that is directed to the most industry-ready startups. And we're in fact about to unveil our latest cohort, so please stay tuned to that. And you can post opportunities. These are mostly challenges that we share with all the startups. And they can apply to it, and then you'll select the ones that seem to be the best fit to help you solve your internal challenges. And now I'd like to share with you some key takeaways of a report we did in partnership with the Innovation Leader about the changing landscape of corporate and startup engagement. We surveyed leaders of large organizations and entrepreneurs. We interviewed some of them as well. And 80% of the corporates said that throughout the pandemic, they were able to increase their startup efforts. 55% of the corporates said they still need to develop an internal process to work with entrepreneurs, for which the engagement of CEOs and CTOs is vital. And when it comes to challenges, corporates mention again, or they reiterated the importance of involving decision makers in the process, as well as the different operating speeds that can be really significant between corporates and startups. And then the entrepreneurs mentioned again the length of the engagement process, as well as how to navigate a large corporate and being connected to the right person. So these are just a few takeaways of the report, but you, as an ILP member, you can download the full report from one of our websites, ILP or Startup Exchange. And we have as well an excerpt that is available to the public. We highly encourage you to read it, and we hope that you find it as useful as we did. And now, it is my pleasure to kick off the lightning talks. And the first speech of the day is from Peg Yu, CTO from Mobi Systems.
Hello, everyone. I'm Peng Yu from Mobi Systems. Really nice to meet you today. At Mobi, we provide a cloud-based computation system to solve planning problems in travel and transport domain. So planning is all about generating a sequence of activities that achieve a collection of goals subject to temporal, spatial, and preferential constraints. It's particularly hard to solve in travel and transport, first because of the scale. Just think of how many, let's say, infrastructure the local MBTA has to support everyday travel, and also how complex it could be. Again, think about, for all your daily movements, how many requirements, constraints you are considering. So that's actually what we aim to solve through our platform, which is first to provide a very, very fast planning solution in seconds instead of hours. And then the key that capability will enable is instead of generating a static plan and then people take it and then adapt manually, we become the planning system that will just operate behind the scene continuously without manual intervention. And then second, we can really model highly complex scenarios so that minimize the gap between what solution we provide, which is a plan, to what can actually be taken to execute on the ground. More specifically, there are so many different types of planning problems, but we focus on three, which is all related to movement. Starting from the bottom level, how do we go from location A to location B, utilizing all modes of transportation, public or private? And then on top of that, how can we solve the sequencing and scheduling problems when we have multiple activities, tasks that have to be chained together? And then finally, one layer on top of that is what if we have multiple agents, multiple resources, inventories, fleets that we have to coordinate to provide the best service so they show up at the right time and the right location. So I want to share two use cases we're working on with you. First one is about routing. So at both city and the country level, our planning system is combining the public and private modes together. In New York City, we are connecting essential workers during the off hours when they shut down the subway system so they can get to where they want to go, either hospital healthcare location or back home. And then in Switzerland, we're kind of solving the problem the reverse way, connecting the core rail system with other modes of transportation, local bike share, car share, so that all the riders can have an end-to-end solution tailored to their specific needs for that particular trip. And then the second use case is at the network level. We're working with one of the largest tourist companies in the world, coordinating all their global transfer fleet. So all the travelers arriving at the airport, trying to go to an excursion, going to the cruise port, going to one of their hotels, depending on which flight they arrive at, can have a solution, can have a vehicle waiting right outside to take them to where they want to go. And then depending on the change in environment of flight delay, we will just replan automatically behind the scene. So that's what we do at Mobi. We're looking for partners with similar challenges. Planning problems that are highly complex, require high accuracy as well as real-time responses. And we would like to work with you. Thank you.
Hi everyone, I'm Dr. Fei Wu from Manus Robotics. We are developing a new type of sensor technology that can greatly enhance the functionality and accessibility of assistive devices, so more people with reduced limb functions can enjoy better independence. Currently, there are over 500 million people around the world who are handicapped and require daily living assistance. These can include amputees as well as those suffering from diseases such as stroke, spinal cord injury, and even osteoarthritis. Hiring someone to take care of these patients 24/7 can become very costly, and patients themselves don't want to have someone to watch over them all the time. Even though many technologies exist to help people in these situations, most of the existing solutions require a lot of time and effort to learn to use well, especially for this population, whose conditions actually change over time because they're deteriorating. And so it's not very surprising to see that many assistive devices end up being abandoned over time because patients feel like they're not just getting the immediate assistance they actually need. So my team and I, after evaluating many assistive devices, found out that the core of this issue is actually in the type of sensor and algorithm used to detect user intent. So the current sensors actually capture signals from the user that are inherently noisy, very easily corrupted, and just not very consistent. And that's why they require a lot of processing and training. But that's just not very desirable when you want to offer great user experience. So that's where we come in. We have developed a new type of sensor that can quickly and reliably detect user intent from small gestures, for example, the wiggle of a finger, which many patients actually can do even with their impaired hand, and use that to control the action of assistive devices. We have so far tested our sensor on over 50 patients in the greater Boston area, including Daniel you see here, who has been struggling with activities of daily living for the past 7 years because of a stroke. When we first tested our sensor with Daniel, we just gave him a very simple 3D printed wearable robot with our sensor embedded in it and just handed it over to him to play with. Within 1 minute, he was already able to control this robot by wiggling his pinky and thumb to open bottles and bags just by himself. And he was so excited about this. He told us this experience completely changed his perception of how easy it can be to just pick up and start using an active assistive device. And he especially liked the fact that the device worked on top of clothes, so he didn't have to roll up his sleeves in the middle of the cold Boston winter. This innovative technology works by optically measuring local blood flow changes caused by muscle contractions. So when a gesture is performed, a particular set of muscles within the arm would contract and result in a specific pattern of blood flow changes around those muscles. Our sensor can pick that up and convert those into unique gesture codes that are unaffected by natural variations in gesture performance. And that's why we're able to achieve over 98% of prediction accuracy with just 30 seconds of calibration without involving extensive user or model training. Compared to other technologies that can be used to control assistive devices, for example, electromyography or ultrasound, our technology can self-calibrate and adapt to users' current condition. And we can even actively control the source of the signal by tuning the light intensity, pulsing pattern, sensitivity, such that we can capture blood flow activity from deeper layer tissue through clothes and still get a very clean signal back for prediction. We plan to work together with assistive device manufacturers to put our sensor into their product. And so right now we're looking for co-development partners and pilot partners in the prosthetics, exoskeleton, and other personal care robotics areas. And this being an enabling technology, we also welcome the opportunity to work together with other partners to explore other interesting markets, for example, AR, VR, general human-machine interface, and even muscle activity analytics. Thank you.
Good afternoon. My name is Alain Briançon. I work for Cerebri AI, and glad to be back on campus. Which button is it? Not this one. The red one? Oh, the big green one. Sorry. Perfect timing if I want to talk about intelligence. So when we have customers that are more and more dealing with the multiple channels that corporations are supporting, figuring out what they're doing, what they want to do, and the like becomes more and more complicated. There's a lot of AI solutions, but the main problem is when you're looking with customers, when you're looking with individuals, you have to do it very quickly. And the pattern that they're exhibiting touching your business through multiple channels becomes quite intricate. So it's nice to have AI. It's great to have AI with the data in real time. So in order to do this, typically you pick up your cloud, you have a source of data, and you start to engineer the data in order for you to extract the most signals that you can out of the system. You apply a set of modeling that are necessary for your applications, and then you expose it to your traditional AI and BI tools. So what we've done is we've developed our own language, our own framework that integrates data, data engineering, logic, operation research, and machine learning all the way to DNNs in a graph approach that allows can think of it as Excel on steroids, allow any business analyst to start mapping the interactions and the processing of data from the raw data we're getting from multiple sources all the way to the insights that are needed to understand the propensity of a customer to do something, their affinity for a product or a service or the like. Once this processing has taken place, then the second part of the platform allows the instantaneous management of the models and actions that can take place, and that can be done at scale. The processing end-to-end is less than a second for all of the application we look into, and we can scale to millions of interactions per second. We've been in business for about 5 years, and we've been providing support and solutions to a slew of Fortune 500 companies. You see some of our partners at the bottom and some we've gone through. Recently, we've been really tackling the problem of churn, mostly for telco company, but the churn, if you have a SaaS platform or a subscription service, is pretty much the same as what these telco companies will have. So this platform, when pressing on the right green button, allows you to perform state-of-the-art customer support for the customer by integrating in one place the data engineering functions that are necessary to manipulate the raw data that you extract from your CRM, your ERP, your sensors, your routers, and the like, and transform them in order for you to extract the right signals. It has decisions engines that are distributed and can be workflow organized as a workflow. And it allows you to score your customers and decide what action to take at scale. Our ask is if you are managing interactions, including digital interaction with customers, we'd like to talk and work with you. In some cases, we provide the end-to-end solutions. In other cases, we provide elements of the solution that are embedded then in third-party solutions. Thank you very much.
Good morning, everybody. My name is John Greenfield. I'm the Vice President of Business Development and Partnerships at Everactive. It's great to be back in person. This is one of my first events, so thank you to MIT for hosting the event, and also for really launching the careers of our two founders who did their PhDs here over a decade ago with Professor Chandakasan. In the industry, we've been talking about the IoT for a number of years, but what we've observed and what many others have observed as well is that many companies are still struggling to drive value with it. Just one of the studies, this one from Bain, cited a couple of specific reasons. One was around scalability, one was around risk, another around the challenges around security. Already talked about some of those earlier today. And then finally, the bottom line impact of these kinds of solutions. So at Everactive, we've focused on solving the core problems that have been hampering the scale of the IoT and, from our perspective, the value of it. One of the things that we do in order to do that is design and use our own semiconductors that operate at 1,000 times lower power than what you can get off the shelf today. In addition, that allows us to build fully wireless, fully networked devices that are operating entirely from harvested energy. So think small amounts of indoor light, lower than what we have in this room today, and small differences in temperature. So 5 to 10 degrees Celsius is enough for these devices to operate. In addition, custom wireless technology allows us to communicate hundreds of meters, even in dense industrial environments. And the focus that we've taken as a company is to bring these solutions to market as a service. So focusing on low upfront investment, the fact that you can get the data flexibly, and then really focusing around the impact, whether that's in dollars or in energy. We have two full solution products or full stack products available today. The one on the left here is focused on steam distribution systems, and the one on the right is focused on rotating equipment. So you can see both focused in industrial and manufacturing environments. They take data such as temperature, relative humidity, and vibration, and wirelessly communicate it and do edge computation, all on harvested energy. You can see some of our customers there in the middle, and some of them we're happy to have here with us today as well. Now, and this is really the next stage of our company, we're going to be focusing on taking the core technology platform that we've used to develop the products and making that available for others to build on top of and innovate on top of. So that's really the second half of the slide that you see here. So we're really excited to see and learn about the other applications that you're interested in using and utilizing this technology for. So from our perspective, we have a couple of asks. One is very straightforward. If you have steam distribution systems in your manufacturing, or you have pumps, motors, fans in your factories, consider using the existing solutions that we have. And then on the newer side, if you're interested in the platform offering that we covered very briefly, reach out and let's talk about having you join our customer discovery platform or customer beta next year. We are a core technology company at heart, and therefore you can see from the top left to the top right here, we're continuing to innovate and make these types of systems available and operating in many more environments and to be more intelligent. Please feel free to reach out. Thanks for your time, and look forward to talking with you later this afternoon.
All right, my name is Eduardo Torrealba. I'm the co-founder and CEO at Meter. We're building accessible, affordable, industrial CT scanning systems. So I'm very fortunate to be a part of a really amazing team that has done a lot of fantastic work shipping hardware and software to some of the most innovative companies in the world. My co-founders are MIT graduates. We've worked at companies like Autodesk, Formlabs, Intopology, Desktop Metal. And we've been on the forefront of building tools that have enabled engineers to design and fabricate products in really innovative new ways. And as we've been working on these problems for several years now, we've seen that it's easier than ever for engineers to design and produce increasingly complex parts. I really enjoyed the talk that we had earlier about digital materials, and that's something that I worked on myself for several years at Formlabs. And it's really important to realize that even if you can produce these amazing digital materials, unless you know that the designs that you made and the parts that you made are matching up to one another, you can never be confident that you can actually ship those products to customers and solve real problems for them. And so what we wanted to do at Meter is solve that problem. We wanted to close that loop between the amazing digital design and manufacturing technologies and the end inspection for those parts. So the way that we're doing this is we're building a super low-cost, very easy-to-use computed tomography ecosystem. Computed tomography is just a fancy way of saying three-dimensional X-ray models of parts. We can scan items in our machines and turn those into data that engineers can then consume and answer pressing questions about the things that they're making. We've been able to develop revolutionary new technology that makes actual CT scanners 10 times less expensive than they've been traditionally. And we've built our entire software ecosystem to make running the systems, consuming the data, and sharing the data with colleagues easier than ever before. Some of the things we can do with our software include doing porosity measurements. So you can put an object in our scanner, scan it, and then find out all the voids inside the part. This is extremely important for things like casting, injection molding, 3D printing. You want to make sure you have solid parts. We can also do Cad comparisons, so full geometric analysis for parts to see if they're matching up with the intention from CAD. This is important if you are taking apart and doing post-processing steps to it. Maybe you're doing some machining. You want to make sure everything's going to fit together. It's super important to have that right for all of your parts. We can also inspect entire assemblies, so multiple different materials combined. We can scan them. This is a water bottle that we scanned as a demo asset for a potential customer. And we've been able to see how all the different seals and gaskets and interference fits match up inside of that system. And finally, we're able to do extensive 2D measurements. We can go in, we can look at things, we can do real non-destructive testing in a way that provides a lot of values for our customers. So, ultimately, everything is about solving problems for our customers. That's the reason our company exists. And Aristocast has been a great partner for us. They're an advanced casting facility company in the Midwest. They work with a lot of automotive and aerospace customers, and they've been able to get rid of some of their traditional destructive testing methods and stop using antiquated 2D X-ray technology and switch that over to CT scanning for the first time, thanks to the products that we've built. Today, we're working with dozens of customers all over the country in a broad range of industries. One of my favorite examples that's come up recently is a fertilizer company that wants to CT scan the root systems of plants that have been fed fertilizer to see how those evolve differently between various plants with various fertilizers. It's not the sort of thing that you think you're going to do when you first start a company like this, but it's really fun to interact with customers and learn about the problems that we can solve for them. So if you work in any of these industries or you work with any engineers that produce real physical parts, I'd love to talk to you a little bit more in the exhibit hall after this. Thanks so much.
Good afternoon, everybody. Very nice to meet you. My name's Cyrus, and I'm the CEO of Leela AI. I'd like to tell you a little bit today about what we're building, our product called Understand Video, which is a new generation of machine vision-related technology to help solve real-world problems. And I went to MIT, and I was a year up at the Media Lab, and so did two of my co-founders. What we're noticing in talking to a lot of customers, and even before we started this company, there's a big problem in the world of AI for machine vision understanding today, in that the solutions out there take a long time to deliver. And we all agree, I think, that applying machine vision to a lot of problems in environments is a very valuable thing, understanding what's happening using a smarter camera. That's something we all want. But how long does it take? And when you have different manufacturing, whether it's pharmaceuticals or any other kind of manufacturing situation, you want the system to understand what's happening. And what you do in a standard setup is you get a lot of data, very expensive sometimes to gather all this data, and then you do many different steps to that data so that you can train a model. And then what happens after that is you may deploy that model. And when you deploy it, you may find that it does things that we weren't expecting. And anyone ever had that feeling when they deployed an AI model and it did something they didn't expect? Raise your hand. Don't be shy. You can, yes, all right, we have, yeah. See, it does happen. It does happen very often. And so then you enter this loop where you deploy and then you go back and retrain and deploy, and that can take sometimes months to deliver value. And so we felt that there was an opportunity to shrink that cycle time from months to much, much shorter times. And if we could do that, we could really deliver value. And so we've been working on this for a while. And we've created a solution called Understand Video, which is a no-code and teachable AI system that has very short cycle times for machine vision, but also can handle other types of input other than video. Here's a video example where you have our system, and that's our teaching interface or teaching tool that lets our users teach the system how to understand new activities that it's never seen before very, very quickly. It can take days instead of months, and the very important thing is that because of our architecture, it can always explain why it's making a certain decision about what it's seeing. And that makes maintenance more efficient. If you want to maintain your machine vision system, you want it to get better and learn new things, new use cases on a daily basis, let's say. If it takes months to train, it's not efficient and won't deliver the value. And the way we do this is we've taken not the pure monolithic neural network architecture, but we've mixed many different kinds of architectures, including monolithic neural networks, with symbolic networks. And we have a hybrid system that we've invented, proprietary innovative technology that was actually originally invented at the MIT AI lab, where some of my co-founders used to work. And it lets us understand new things like causality and hidden state and transfer learning, lots of very interesting properties that come from this new breakthrough innovative technology. And so at one of our customer sites, we've noticed that people are finding that they can really get at this visibility into productivity. What's taking longer? What's taking shorter? Are people moving too much? Are they using their hands in the most efficient way? If it's a very manual process where people are working with machines or robots. And then the next thing we've noticed is that they really want to do this kind of digital transformation, connecting the real world with the electronic or digital world. And how do we go paperless? How do we stop all these inefficient practices? having a video system that can really quickly understand many, many, many different use cases can really help support that transition in that digital transformation. And of course, you know, if there's something going on that's not safe or something that's not complying with your internal rules and regulations about how things should be done, standard operating procedure, our system can detect that and then help change. So I'd like to first thank you all for coming today and ask you, if you are interested in this technology, come see me and my co-founder Milan Minsky. She's also going to be at our table today, and we'd love to talk to you about how we could work together, how we could partner. We're looking for partners right now who are doing manufacturing or related areas to manufacturing, like logistics and distribution. Imagine using an AI-enhanced camera to digitize complex activities and really meld that data with other data streams that you're getting from other sources. We have many different ways of implementing. We're very open to both on-premise and cloud-based models. We want to find ways to work with you that are easy for you to work with us. If you have issues with efficiency and trying to optimize efficiency, compliance, and safety, those are the focuses we're doing right now with our customers, and we'd love to see if you have those similar challenges that you're facing. If it's manual tasks that involve machinery, that's one place we've seen a lot of success with, but also could be interactions between machinery and other machinery and robots. These are things that if you have a system that can look at and understand, you can get a lot of rich, really benefits from this kind of system. And the big thing that, you know, makes it sort of easy to get going with our software is it's very quick and easy to teach because, you know, you throw in a little bit of human understanding, but then our system takes what it learns from what the teacher, the human being, is saying and then runs with that and improves its models. So it's very quick to get started. As I said, days instead of months. And you don't really need an existing video infrastructure if you don't have one. We can help you get some cameras in place and quickly connect to the cloud so you can see the benefits right away. I'll be at the booth. We have live demos. We have some video of existing applications. So please come talk to us. We'd love to talk to you. Or just send me an email. Or go to our website, Leela AI. And we'd love to hear more about what you're working on and see if we can help. Thank you very much for your time.
Hi, my name is Beth Porter, and I'm really pleased to be back here again after a couple of years and talk with you a little bit about the evolution of our platform, Riff, and describe how that platform uses AI-enabled feedback to give people information about how they interact, especially online. We started out of the Human Dynamics group, which is led by Sandy Pentland, and part of the problem that we were trying to solve at that time was helping people learn how to interact in person and wearing badges and helping them understand where do you find affinities among groups, where do you find affinities among pairs of people, and what does that tell you about organizational dynamics. Now, of course, we're in a completely different situation. Everybody is trying to figure out how to work more effectively together online and in hybrid modalities, and that's where we really shine. So our mission is to help people learn how to interact online and work or learn together from anywhere. And where we really find ourselves right now is in taking on the challenge of improving not just the task side of working together online, but improving and helping identify places where human interaction is incredibly important. Because I think you all know that the ways in which people work best together is those situations where there is transparency and there is trust. And that's the human dynamic of working together. We use clients that we machine ourselves, video and text-based clients that allow us to have a privacy-preserving environment so that the feedback that gets generated is safe for everyone to get and is not used for other than the purposes that we describe it for. We give that feedback in real time, and that feedback has been shown through our NSF-backed research to improve outcomes. So that's both individual performance and team performance and the actual engagement itself, which gives people a much better sense that the way that they're working online is really working. We use voice data primarily to give feedback, and we model the behaviors just based on the vocal record. So we don't need to know what it is that you've said to be able to derive some pretty unique insights. Speaking time is sort of the most trivial of them, although it has some of the most impact to the people who get that feedback. But the main goal is to give you a sense of the total dynamic, how the conversation is flowing, who you have the most affinity. If I look at this gentleman in the front, he knows I'm talking to him and I'm developing affinity right now, right? But that's very hard to do online. I can just do it dynamically here in person. Those are the kinds of insights that we provide. We also have multi-sensing technologies that we're introducing right now that use facial gestural, emotion, and sentiment analysis to help identify affinities. One of our caution points is that we don't want to make a priori judgment about something being good or bad, positive or negative. Contrastingly, we really want to show people where they have activity, highlight that, and then give some possible forms of recourse. We work with leadership development, universities, executive education, embedded in processes like sales enablement, and across the board of any place where human development is taking place. And sometimes that can be in situ, and sometimes that's with a structured program. We work in both those cases. Here with Grant Thornton, we developed a program for their leadership training of interpersonal skills. We collaborate with all kinds of different people. This really is a very universal technology, and we'd be happy to collaborate with you on any of these things. If you want to talk with me, I'll be outside after this presentation. Thank you so much.
Hi, everyone. My name is Elizabeth Maida, and I'm the co-founder and CEO of Fathom. Prior to Fathom, I founded a cybersecurity company which was acquired by McAfee, and I worked for many years at Akamai Technologies, another MIT-related company. I attended MIT for graduate school and received dual master's degrees in computer science and engineering systems. Now, Fathom's mission is to simplify access to biomanufacturing data. Our vision is to aggregate and analyze data from throughout the manufacturing process to enable real-time visibility. In biopharma, there's been a lot of focus on applying AI and ML for the purposes of drug discovery, but manufacturing data has been largely overlooked, despite its criticality for biologics and cell and gene therapy. In our experience working with pharmaceutical companies, we've seen that the majority of this data is still trapped on paper and in legacy ERP systems, meaning that the only ways to access this information are through very manual, time-consuming, error-prone processes, even though the data can have a critical and direct impact on the efficacy of the therapies. So why is manufacturing data so important? There's been a fundamental shift in the industry from chemical compounds to biologics, or therapies that are created by replicating biological processes. With chemical compounds, it's fairly straightforward to characterize the output and assess the quality of the product. There are standard tests that detect which elements are present and identify any impurities. But with biologics, the only way to characterize the output is to really measure the process by which it is manufactured. Data is generated throughout the manufacturing life cycle and stored in disparate systems and oftentimes on paper. While Fathom's long-term roadmap includes directly integrating with lab equipment, our initial focus is on the documents. Fathom has developed domain-specific OCR and NLP technology that automatically extracts and validates data from these documents, performing tasks like automatically confirming handwritten calculations, checking to see that all initials and dates are present, and making sure that the actual data doesn't contradict scientific realities. Quality teams can then use this information to quickly assess the therapies, proactively identify any issues, and accelerate the batch release process. As an example, we're currently working with an allogeneic CAR-T therapy company who receives donor cells and then genetically modifies them so that they can be injectable into anybody without worrying about immunoreaction. It's a 19-day manufacturing process, so they often send the cells out to other labs to get tests done and then handwrite the resulting measurements into their batch records. Their biggest source of concern is human error, And if they can catch those errors early enough, they can actually minimize the likelihood that the cells will die. These batches amount to about $2 million each, but it's not just the financial implications, as these are life-saving therapies. In this case, we were able to reduce the quality review time by 80%, from 35 days down to around 7 days, and also generated data that manufacturing sciences could use to analyze critical process parameters, analysis which is required by the FDA for regulatory compliance. We're looking for additional partners in the biopharmaceutical industry, including contract manufacturing organizations, to collaborate with us on this area. While we're primarily focused on quality teams, we're also very interested in connecting with manufacturing sciences and process development. So please contact us at liz@fathom.one or come by our booth during the exhibit showcase after this session. Thank you so much.
Jaxon is University for AI. AI has a big secret. As you've seen from many of these presentations, models need to be trained. They're trained on representative examples that have been labeled. The labeling task today is predominantly done by humans. Depending on whether it's an unsupervised or supervised learning model, most in-production systems today are supervised learning, with teams of humans behind the scenes, labeling data one at a time, tens of thousands, if not hundreds of thousands of times over. And as many of the presentations have alluded to, it's not just a time and cost issue, it's also that humans make mistakes and bring this inaccurate learning into the training pipeline that then produces models that have, again, an inherently flawed starting point. Jaxon is automating as much of the process as possible. We have not eliminated those pesky humans yet. We like to say that the humans are designing the factory. They're no longer working on the assembly line. So humans are there to design what the problem is, look over the shoulder of the machine and ensure the accuracy of the output, and then use the trained models in their production settings. We're currently focused on natural language processing use cases, so taking in a mound of representative examples from social or chat logs or call logs and using those examples to label and then ultimately train the models with. Here's a case study we did with a large retailer where they did away with the drop-down menu for reason for return because they found everyone would just pick the first option that got their money back. And so they force you to free-form text in write why you're returning the good. So in this example on the bottom left there, the trash can was dented. And then that written example needs to map to, in their case, 64 different reasons for return. Could have been damage, could have been packaging issues, could have been assembly struggles, what have you. So taking the raw example and then mapping it to these 64 different reasons for return. Before Jaxon, this retailer would ship off hundreds of thousands, in this case it was 400,000 of these examples, and waited months for humans to label the data and then give it back to their data science team. So you can see that Jaxon was not only faster, obviously more cost effective, but if you look at the bottom row there, it also produced a more accurate model on the other side, because with Jaxon, it's calibrating and curating the labeled data as it proceeds. Greg and I met at MIT a good 18 years ago. We've been building company after company together since. The last one was a machine learning consulting firm where we worked with large organizations to push their first models to production and always ran into this bottleneck of labeling data. So we decided to start building it 5 years ago, and now we have it in production. We're working with retailers, we're working with the US Department of Defense. We are really industry agnostic, and as long as you have lots of natural language, we can give you lift and accelerate the process of training models. I can be found at Scott at Jaxon.ai. Thank you.
Good afternoon. I'm Pablo Costa. I'm the VP of Engineering of Pressing Devices, and we offer edge-to-cloud data solutions through our low-code platform. So other than being a buzzword bingo, entry, digital transformation produces lots and lots of data. And more importantly, that data is produced at a lot of different physical locations. In an industry setting, could be different manufacturing plants, but even within those plants, it could be different machines. There are loads and loads of sensors, both connected to PLCs, industrial PCs, gateways, or directly to the cloud. And those sensors communicate using an astonishingly large set of protocols, all unique, like snowflakes. Their data is hardly clean. And Murphy's Law applies in that data is usually in a format that the next stage in the data processing pipeline requires. So this is a very complex problem, and we help companies realize the value in that distributed data. We're helping more than 30 companies through this digital transformation process, and we think that we're uniquely qualified to do this. We have, my co-founder and I have more than 20 years of experience in hardware and systems, very complex high-speed mixed-signal chips that we have designed that go into base stations, networking equipments, and other systems like that. And the previous company of my co-founder has more than 10 years of shipping, I think at this point, more than 500,000 sensors in IoT. So very strong team, and I'll give you a sample of the problems that we can solve. One is just managing the data pipeline. So in this case, one of our customers has an AI model that detects defects in the packaging of pills. So we help with the whole system, because of course that model requires an input. So there's a hardware component, like the cameras, connecting the cameras to the right hardware, acquiring the image, making sure that it has the right balance, and other features so that the accuracy of the AI model can be realized. And after that, our customers' customers have different requirements. One customer just requires alerts when a defect has been encountered. Others require information as to what production line cost that defect was located in, all sorts of data analytics. So our low-code platform makes it very easy to implement all these steps, but also optimize where, for example, in this case, the AI model is going to be taking place. It can be at the edge, in the cloud, or both. Another example, one of our customers is in the smart chemical solution business. We help implement an end-to-end solution. This solution tracks more than 100 parameters. It's going to be deployed in more than 200 sites. And the low-code part of our platform actually shines in here that an engineer, not a software developer, just an application engineer, was able to develop the solution part-time in under 2 months. So no matter what industry you're in, if you have complex distributed data solutions or problems that you want to enlist our help with, please feel free to reach out to us. We'll be happy to partner with you and to help you realize the value in your data. As many of the other companies mentioned, we're also in the demo room, and so the immediate ask is just don't be shy, let's talk, and let's see how we can add value to your company. Thank you.